and welcome to this Excel tutorial on financial functions in Excel. In this video, we're going to learn some of the most frequently used financial functions. The first function is discount rates for a security. How do you calculate a discount rate for a security amount? Here we have the settlement date, maturity date, price value, and redemption value. Using these four arguments, we can easily calculate the discount rate using the formula equals disc, open parenthesis, which is going to return the discount rate for a security. Discount rate of settlement date, maturity date, price value, and the redemption value. Then close parenthesis, and this would be your discount rate. And you can convert it into a percentage. These are the discount rate percentages. And the next one is future value. How do you calculate a future value for a settlement that you are making per month? I have my principal amount here. That is $10,000. The interest rate equals 5%. Years. Number of payments per year. The monthly payment amount. And I have to calculate the future value of my investment based on these input fields. I would have to select the formula equals FV, which returns the future value of an investment based on periodic constant payment and constant interest rates. So for this function, we have to maintain constant payment and constant interest rates. Select the formula, click on this formula box. The rate, our first input is the rate. Rate is the interest rate per period. And here our interest rate is 5%. So here, enter 5%. You can calculate it on a quarterly or monthly basis. Let's do it monthly in this example. 5% is for 1 year, so for monthly you divide by 12. NPR is the total number of payment years in the investment. Here the number of years would be our periods multiplied by 12. Since we're taking it for all 12 months, and PMT is the payment made for each period, it cannot change over the life of the investment, which means it has to be kept constant. So here our PMT would be the monthly payment 100. I'm going to take it as negative 100. Why is that? Because whenever money goes out of our pocket, we consider it as a negative value. So I'm going to make a monthly payment of 100, and therefore I'm considering it as a negative value. The next parameter is PV. PV is the present value or the lump sum amount. So here our PV would be principal amount. Again, principal amount is something which goes out of your pocket. So minus. Minus principal amount is what we take it as. And our last field would be the type. If you're going to make the payment at the beginning of the period, the type should be 1. If it's made at the end of the period, then type equals 0. So let's take it as 1 here. And okay, so it shows that the future value of $13,578. You can also change the inputs if you want and arrive at an updated result. If I'm going to increase my principal amount to $20,000, I would have this change reflected in the future value. We can also play around with the rates. Change the payment made per year and you'll get an updated value. But here we would have to maintain the monthly payment and the periods as constant. So the next function is the NPER function. NPER refers to the number of payment periods. This function is used to get the number of payment periods for a loan, given the amount, interest rate, and the periodic payment amount. I have my data here. The loan amount is $5,000. The interest rate is 4.5%. The monthly payment amount is $93.20. And the compounding periods per year is 12, which stands for the 12 months in a year. Now I want to get the number of periods for this loan amount, $5,000. To arrive at this, we can utilize the NPER function, which is equals NPER rate, and the rate here is 4.5% for the entire year. So I have to calculate the periods in terms of months. The rate will be 4.5 divided by 12, which will give me the rate per month, comma, the payment amount, and this is going to be the same as the monthly payment, which is $93. So select that, comma, the present value, or PV, and the PV here is the loan amount, which is $5,000, and I'm going to take it as negative $5,000 because, once again, any money which is going out of my pocket is always taken as a negative amount. Since the loan amount is something I have to pay, I'm taking it as a negative value. The next two arguments, future value and the type, are optional. And we close parenthesis, hit enter, and I now have the number of periods for this loan for this amount of $5,000, which is 60 months. Let's now move to the function which is PMT. PMT gives the payment amount for a loan or an investment. Just like we used the NPER function to find out the number of periods using the loan amount and the interest rates, you can find out the monthly payment amount using the periods and the loan amount. So we have loan amount, interest rate, and periods as inputs. Using these, we have to find the monthly payment amount. So to do this, use the formula equals PMT, open parenthesis, rate. The rate here is 5% for the entire year. So for a month, you divide it by 12, comma. NPER is the number of payment periods which we have seen in the previous function, which is 60 here. So select it, comma. The present value is the loan amount, $5,000. And since it's going out of our pocket, we're taking it as minus $5,000. And the future value and type is optional. So close parenthesis, enter. So for paying this loan amount at this interest rate with these many periods, the monthly payment is $93. Let's now move to the next function, which is the rate function. The rate function is a financial function that returns the interest rate per period of an annuity. We have the loan amount, monthly payment, number of periods of payment, and using these we have to find the annual interest rate. The formula would be equals rate of, the number of periods is 60, select it, comma, the monthly payment would be $93, comma, the present value is negative $5,000, which is the loan amount, and enter. Now the interest equals 0%, but this is for one particular period. But to calculate the interest rate per annum, we have to multiply this rate by 12. So 5% is my annual interest rate. Now let's move to the next function, which is NPV. NPV stands for Net Present Value. This function calculates the net present value of our investment using a discount rate and a series of future cash flows. These are my periods of payment, and these are the cash flows. And this is the discount rate. So using these, we have to calculate the net present value. The formula for this would be equals NPV, the rate, the required return rate is 10%, select it, comma, we have to select the number of series of cash flows. I'll go ahead and take it from period 1 to period 5, and these are my future cash flows. Close parenthesis, enter, and we have the net present value is $1,000, from which I have to remove the cash flow, minus $500, which is already done. So since it's negative, I'm taking it as plus the cash flow, and enter, and then we have $565 as my net present value. And let's move on to the last function, which is FVSCHEDULE. FVSCHEDULE stands for Future Value Schedule. This function calculates the future value schedule, the future value of an investment with a variable interest rate. This is my principal amount, which is $10,000, and these are the interest rates for 5 years. Using these two, I can calculate the future value schedule, and the formula is equals FVSCHEDULE, open parenthesis, of the principal amount, select it, comma, the schedules, these are my scheduled interest rates for 5 years, and we close parenthesis, hit enter, so $12,105 would be the future value schedule value. And there you have it. These are some of the most commonly used financial functions in Excel. Thank you for watching, and we'll see you in the next video.